morning, everybody. My name is Gaurav Chaudhary. I am Assistant Professor in IT Department at AKGEC Engineering College, Ghaziabad. Today, I will be discussing the topic of Data Analytics Lifecycle, which is part of the subject Data Analytics of the 6th semester. So before I go on to the Data Analytics Lifecycle, I would like to elaborate the difference between data analytics and data analysis, because it can be confused with data analysis. So your data analytics is often confused with data analysis. While these are related terms, they aren't exactly the same. In fact, data analysis is a subcategory of data analytics that deals specifically with extracting meaning from data. So when you extract meaning from the data, that is your data analysis, because your data initially is unstructured, and it may be semi-structured, it may be structured also, but it will not give you the meaning. You have to draw the initial meaning of the data. So when you extract meaning from the data, that is known as your data analysis. Whereas data analytics as a whole includes processes beyond analysis, including data science, which is used to theorize and forecast, and data engineering, which is used to build data systems. So data analytics will comprise both of your data science and data engineering, whereas your data analysis is just to extract the meaning from the initial available data set. Now, what is the data analytics life cycle? So the data analytics life cycle is a series of 6 phases that have been identified as vital for businesses doing data analytics. So there are 6 phases, and it is a cycle from 1 to 6 in back to step or phase 1. So this life cycle is based on popular CRISP DM analytics process model, which is an open standard analytics model developed by IBM. The phases of the data analytics life cycle include defining your business objectives, cleaning your data, building models, and communicating with your stakeholders. So the CRISP DM stands for Cross Industry Standard Process for Data Mining, is an industry proven way to guide your data mining efforts. So your data mining efforts and your data analytics efforts, they sort of converge and convey the same meaning. Now this is your data analytics life cycle. So in this life cycle, we can see the 6 phases of data analytics, starting from phase 1, which is discovery, then phase 2, which is data preparation, then phase 3, which is model planning, and then phase 4, which is model building, then phase 5, which is communicating results, and then lastly the phase 6, which is operationalizing. So this is the way you will carry on or proceed for doing data analytics on your data set. So these are the 6 phases of the CRISP DM model, and this is widely accepted as an industry proven model for carrying out data analytics. So coming to the phase 1, which is discovery. So before you carry on making model, choosing model, making model, and then carrying out data analytics, you have to first discover the context of the problem. So the first phase involves getting the context around your problem. You need to know what problem you are solving and what business outcomes you wish to see. So what problem you are solving and what business outcomes you wish to see. You should begin by defining your business objective and the scope of the work. So business objective and scope of work. So you have to work out what data sources will be available and useful to you. For example, Google Analytics, Salesforce, your customer support ticketing system, or any marketing campaign information you might have available. So these all are your data sources which will be available and useful to you. You have to identify the data sources which will be useful to you. After identifying the data sources which will be useful to you, you have to perform a gap analysis of what data is required to solve your business problem analysis compared with what data you have available. So is there any gap in the data you need to perform your business and analytics, and the data which you have which is available? So if there is a gap, then you have to work out a plan to get any data that you still need. So once your objective has been, business objective has been identified, you should formulate an initial hypothesis. So hypothesis is what? It denotes the output of the learning. Your output can be of different type, different classes, and your output of different classes is denoted as your hypothesis. So you should formalize an initial hypothesis, what kind of output you would like to achieve. So then you design your analysis so that it will determine whether to accept or reject this hypothesis. So you have to design your analysis. This is the design phase only. You have to design the analysis that will determine whether to accept or reject this hypothesis, whether your output will be what you are going to achieve will be accepted or rejected based on some criteria. So decide in advance what the criteria for accepting and or rejecting the hypothesis will be to ensure that your analysis is rigorous and follows the scientific method. So in discovery phase, what you are doing is you are first identifying the data sources, and then you are designing your analysis. After formulating the hypothesis, you are designing the criteria whether to accept or reject the hypothesis. Now coming to the second phase of the data analytics life cycle, which is your data preparation. So now you have to prepare the data for the analysis and further analytics purposes. So in the next stage, you need to decide which data sources will be useful for analysis and collect the data from all these disparate sources and load it into data analytics sandbox. So it can be used for prototyping. So data analytics sandbox, as we know, is you move the data to the processing area. That is your data analytics sandbox. Instead of moving the data, moving the processing to the data, you have to move the data to the processing area. So when you load your data into the sandbox area, you will need to transform it. So there will be again, when you will be transforming it, there will be again your analysis transformations and also your analytics transformations. So your analysis transformations can also be called as your pre-processing transformations. So you give meaning to the data. You have to move towards making it more and more structured, so that you are able to extract more and more meaning from the data and make it more meaningful. So the two main types of transformations are pre-processing transformations and analytics transformations. Pre-processing means cleaning your data to remove things like nulls, defective values, duplicates, and outliers. Analytics transformations can mean a variety of things, because analytics, as we know, it comprises both your data science as well as your data engineering. So analytics transformations can mean a variety of things, such as standardizing or normalizing your data, so it can be used more effectively with certain machine learning algorithms, or preparing your data sets for human consumption. For example, this is an example of consumption, where you can actually consume the data straight away after transforming it. So you transform the machine labels into human readable ones, such as your machine label is SKU123, which is being transformed into machine label into human readable label, which is t-shirt brown, so that you can act on this data straight away. Then, depending on whether your transformations take place before or after the loading stage, this whole process is known as your ETL, which stands for it's a synonym for extract, transform, load, or ELT. With here the sequence will be extract, load, transform. So whether it is before or after the loading stage, your transformations take place, your transform operation will take place accordingly. So you can set up your own ETL pipeline to deal with all of this. You can automate this process also. You can have your own pipeline, or use an integrated customer data platform to handle the tasks all within a unified environment. So you have the environment in which you are working, there you have this integrated customer data platform. If you don't have your own ETL pipeline, you can use that integrated customer data platform to handle the task in the unified environment. So it is important to note that the sub-steps detailed here don't have to take place in separate systems. It is not necessary that the data should reside in all the data on which you are acting, it is residing on separate systems. It can either be in the analytics sandbox, or for example, if you have all the data sources in a data warehouses or data warehouse already, you can simply use a development schema to perform your exploratory analysis and transformation work in the same warehouse. So exploratory analysis, you will be doing your explanatory analysis also before you do your exploratory analysis, because your explanatory analysis maps to your pre-processing operations, whereas your exploratory analysis maps to your analytics transformations operations. Coming to the phase 3, which is your model selection. So a model in data analytics is a mathematical or programmatic description. It is either mathematical model, or it is the programmatic description of the same mathematical model, or it is just a programmatic description of some function. So that will again be your model only. So a model in data analytics is a mathematical or programmatic description of the relationship between two or more variables. It allows us to study the effects of different variables on our data and to make statistical assumptions about the probability of an event happening. So data analytics, because we know that it basically deals with forecasting, so we will be finally taking up the problem of the probability of any event happening, mostly. So because there can be other outcomes also apart from just describing the probability of an event happening. The main categories of models used in data analytics are SQL models, statistical models, and machine learning models. So here you have to decide which model you are going to choose for your data analytics problem. So a SQL model, out of these three models, a SQL model can be as simple as the output of a SQL select statement, which is it can be a very simple model having just a select statement, and these are often used for business intelligence dashboards where you want to visualize the your output of the analytics or the outputs of your model. A statistical model shows the relationship between one or more variables, a feature that some warehouses incorporate into more advanced statistical functions in their SQL processing. So the model is about there is some function, and the function is having one or more variables, and there is a relationship between one or more variables described by that function. And it can also be a machine learning model which uses algorithms to recognize patterns in data and must be trained on other data to do so. Machine learning models are often used when the analyst doesn't have enough information to try to solve a problem using easier steps. So if you are unable to do it by using by using simple models such as you can say your SQL model a simple SQL model you are unable to do so, or using some statistical models you are unable to do so, then you will use your machine learning models. So you may want to think about the following points when you decide on a model. What are the points you should decide when you should decide on the model for your data analytics problems? Till this stage, you have completed your pre-processing transformations. You have identified your data sources. You have completed your pre-processing transformations and your analytics transformations. Now you are deciding on the model, which model to select out of these three models. So how large is your data set? While the more complex types of neural networks with many hidden layers can solve difficult questions with minimal human intervention, be aware that with more layers of complexity, a larger set of training data is required for the neural networks approximations to be accurate. So you can have more layers of complexity in your neural networks, which is your hidden layers, and with more layers of complexity you will require a larger set of training data so that your approximations are accurate. The larger the complexity of the data, the larger the data set requirement. You may only have a small data set available, or you may require your dashboards to be fast, which generally requires smaller or pre-aggregated data. So depending on your data set, you have to decide on the model, which model you have to select. So how will the output be used? This is another factor to think upon. In the business intelligence use case, fast pre-aggregated data is great, but if the end users are likely to perform additional drill downs or aggregations in their business intelligence solution, the prepared data set has to support this. So a big pitfall here is to accidentally calculate an average of an already averaged metric. So you should use the average of the metric which you are using for aggregating your data set. If you require additional aggregations in your business intelligence solution. If your data is labeled with column headings, then you can go for supervised learning, and if it is not labeled data, then you have to go for unsupervised learning. That is your only option. So then another point to think upon is that, do you want the outcome to be qualitative or quantitative? So if your question expects a quantitative answer in terms of quantity, for example, how many sales are forecast for next month, or how many customers were satisfied with our product last month. If you want the number, if you want the quantity, then you should use a regression model. However, if you expect a qualitative answer, for example, is this email spam? If you want a qualitative answers in terms of prediction or classification, for example, is this email spam, where the answer can be yes or no, or which of our 5 products are we likely to have the most success in marketing to customer X? So which of our 5 products has the highest probability of giving us success in marketing that product to customer X? Then you may want to use a classification or clustering model. So either you can go for statistics or you can go for machine learning. In statistics you will go for regression, whereas in machine learning you will go for classification or clustering of a clustering kind of model. Then another point to think upon is accuracy or speed of the model, which is important to you. Whether you are giving more priority to accuracy or you are giving more priority to speed. If so, check whether your chosen model will perform well. The size of a data set will be a factor when evaluating the speed of particular model, because larger the data set, it will require larger training times, and it will be a factor in choosing your model. So then another factor is your data unstructured? Because data can be structured, unstructured, semi-structured, or quasi-structured. We can have 4 kinds of structuring in the data, which is, or the data set which is available to us. So if your data is totally unstructured, then unstructured data cannot be easily stored in either relational or graph databases, and includes free text data such as emails or files. This type of data is most suited to machine learning, because if it is some kind of, say, relational data, if it is structured, then it will be suited to your SQL kind of model, though you can also use your structured data for your machine learning purposes also. You can use that. There is no hindrance to that, but it is all that we are saying is that your unstructured data is most suited to machine learning. You can use your structured data as well for machine learning purposes. But when it comes to suitability, then you will find that mostly your unstructured data is suitable for machine learning. Then another point to think upon is, have you analyzed the contents of your data? So have you gone through in detail while analyzing the contents of your data? Analyzing the contents of your data can include your univariate analysis or multivariate analysis, such as factor analysis or principal component analysis. So there are methods for doing your for analyzing the contents of your data, and this allows you, after this kind of analysis allows you to work out which variables have the largest effects and to identify the factors that are combination of different existing variables that have a big impact. So you have to identify the important variables which will give you maximal impact on the learning from the data. So in order to identify those variables, you have to do your analysis on the contents of your data, and once you do the analysis on the contents of your data, you are able to identify the important variables, because there can be many variables. They cannot be it is not that your data will provide you the important variables automatically. You will have to extract from the data the important variables which will give more meaning to your data analytics, which are important for the data analytics. So this is another factor for while selecting your model, which model you will select. out of these three models, which is SQL model, statistical models, and machine learning models. Now coming to the fourth stage, which is building and executing the model. So now we have selected the model which we are going to use. So then we have to build the model and we have to then execute the model on the data set. So once you know what your models should look like, you can build them and begin to draw inferences from your model data. So now you have to build them and then you have to execute to draw inferences from your model data. The steps within this phase of the data analytics lifecycle depend on the model you have chosen to use. The steps so depending on the model, every model will have its own steps, how you will go on building that model and how you will go on executing that model. So when it comes to SQL model, building your SQL model, you will first need to find your source tables and the join keys. So you will have to identify the primary keys or the super keys for joining your source tables when and where required. Next, determine where to build your models. Depending on the complexity, building your model can range from saving SQL queries in your warehouse and executing them automatically on a schedule, to building more complex data modeling chains using tooling like DBT or Dataform. So either you can have a simple model having some saved SQL queries in your warehouse, or you can build more complex data modeling chains where your data modeling will go through your chains or sequence of operations. And after doing so, then you have to create another model to extend it so that your base model can be reused for other future models. So your base model will be either your saved SQL queries or it will be either a complex data modeling chain, and then you will have to extend your base model to another model so that it can be used for future models. Now you need to test and verify your extended model and then publish the final model to its destination. So now comes the testing and verification part of your extended model of the base model, and then you have to publish the final model to its destination. You have to save the final model and publish it to its destination where it will be used for executing on the dataset. For example, a business intelligence tool or reverse ETL tool. So when it comes to building your statistical model, you should start by developing a dataset containing exactly the information required for the analysis and no more. Next, you will need to decide which statistical model is appropriate for your use case. For example, you could use a correlation test, a linear regression model, or an analysis of variance ANOVA test. Finally, you should run your model on your dataset and publish your results. When it comes to machine learning model, there is some overlap between machine learning models and statistical models. So you must begin the same way as when using statistical model and develop a dataset containing exactly the information required for your analysis. However, machine learning models require you to create two samples from this dataset, one for training the model, another for testing the model. So you will be creating two samples from the initial dataset. From the one dataset you have, you will be creating two datasets. So there might be several good candidate models to test against data, for example, linear regression, decision trees, or support vector machines. So you may want to try multiple models to see which produces the best result. If you are using a machine learning model, it will need to be trained. This involves executing your model on your training data set and tuning various parameters of your model so you get the best predictive results. Once this is working well, you can execute your model on your real data set, which is used for testing your model. You can now work out which model gave you the most accurate result and use this model for your final results, which will then need to publish. Once you have built your models and you are executing and generating the results, then you have to communicate these results to your stakeholders. Whoever are the stakeholders in your business analytics problems, from where they wish to gain monetarily, you have to communicate those results to your stakeholders. Then stage 5 is communicating results. You must communicate your findings clearly, and it can help to use data visualizations to achieve this. So you will be using data visualizations to communicate your findings. Any communication with stakeholders should include a narrative, list of key findings, and an explanation of the value of your analysis which adds to the business. You should also compare the results of your model. You should compare your model of the results with your initial criteria for accepting or rejecting your hypothesis to explain how much confident you are in your analysis. So once you are generating the results, you have to compare the results with your initial hypothesis and how much confident you are in your analysis, which you will get from your initial criteria for accepting or rejecting your hypothesis. And the last stage is your operationalizing. Once the stakeholders are happy with your analysis, you can execute the same model outside of this analytics sandbox on a production data set. So now you are moving the model to the production data set instead of your initial data set which you used for your data analytics. You should monitor the results of this to check if they lead to your business goal being achieved. If you should monitor the results continuously if your business objectives are being met, deliver the final reports to your stakeholders, and communicate these results more widely across the business and continuously. So to keep up to date your impact of your goal which you want to achieve. So this completes your 6 stages of your data analytics life cycle. Thank you.